1. Types of forces. A force is a quantity vector which is imagination. Therefore, to explain the character of the force that happens, we do it by drawing an arrow which is called free body diagram. The characters of the force that happen are various. Attracting force between the masses. Attracting force between the masses is a force created from two objects which attract each other. It was found by Sir Isaac Newton, who could prove that two objects were pulling toward each other. It led to the explanation of the Earth's gravity and the gravity of the solar system. The size of the attracting force between masses is directly proportional to the sizes of the masses. However, it is inversely proportional to the distance between the masses. The fixed amount of variation, g. F is the gravity between the two masses of which the unit is Newton. m1 is the amount of mass number 1 of which the unit is kilogram. m2 is the amount of mass number 2 of which the unit is kilogram. R is the distance between the two masses of which the unit is meter. G is the amount of standard gravity, which equals to 6.67 times 10 Newton meters squared divided by kilogram squared. Note: because the amount of g is very small, the attracting force between the masses is great when the sizes of the masses are big, such as the Earth, the Moon, the Sun, etc. Those masses are enormous, so their attracting forces are great. Example 1. A planet has the mass of 5 times 10 to the 20th power kilograms and the radius of 4 times 10 to the 6th power meters. How much attracting force does this planet have towards an object of 20 kilograms close to the surface of the planet? Therefore, the attracting force towards the mass close to the surface of the planet equals to 0.04 Newton. Example 2. Two masses staying at 10-meter distance have the gravity of 20 nanonewton. If moving the masses to 5-meter distance, how much attracting force will they have? The attracting force is 80 nanonewtons. Gravity force. The Earth is a huge object. When there is an object close to the Earth, there will be force exerting on each other. This results from the attracting force between the masses. However, the object is small. Therefore, the Earth pulls in the object towards the center of the Earth. We call it gravity force. The direction of the object's gravity force is driving straight down. The force that occurs will focus on the particular spot called center of gravity. When there is an equal amount of force exerting past this spot, that object can stay balanced. From this principle, we can calculate the gravity force by hanging an object or placing it on a spring, then read the amount indicated on the spring as a force called weight. The spring that we use are called scales. In addition, we can calculate the gravity force from the falling of an object. The objects that have different masses, when free falling, they will fall at the same acceleration, which is g. 9.81 meters per second squared, but uses 10 meters per second squared in the calculation. But uses 10 meters squared in the calculation. The gravity force follows the second law of Newton. The amount of the force that occurs equals to the multiplication of the mass and the acceleration caused by the gravity force. F equals mg, or W equals mg. M represents the mass of an object, of which unit is kilogram. W represents the weight of an object, of which unit is Newton. G represents the acceleration from the gravity force, which has unit of meters per second squared. How much weight does a log of 2 kilograms have? The weight is 20 Newton. A knot has weight of 0.6 Newton. How much is the mass of this knot? The mass of this knot is 60 grams. Electric force. 2,000 years ago, a Greek named Thales discovered that if rubbing an amber with fur, the amber could attract a small object. Therefore, the word electricity is from electron, which is amber in Greek. Later, Dr. Gilbert discovered that other objects could produce the same result as amber. At present, it is discovered that there are 2 types of electrical charges, which was identified in At present, it is discovered that there are 2 types of electric charges, which were identified in 1750 by Benjamin Franklin, an American physicist. When rubbing a glass stick with silk fabric, a positive charge will occur on the glass stick. However, when rubbing an amber on fur, the amber will have a negative charge. At present, it is discovered that 1. Positive charge is a charge on a particle called proton, which is a small particle in the nucleus of an atom. Each proton has charges of 1.6 times 10 to the negative 19th power, coulomb. 2. Negative charge is a charge on a particle called electron, which circles around the nucleus of an atom. Each electron has charges of negative 1.6 times 10 to the negative 19th power coulomb, which is equal to the protons. The property of electric charge. 1. Ability to attract small object. An object which has free charges is able to attract small objects such as small pieces of paper, dust, and soot. If you rub a plastic ruler with your head and bring it close to a small piece of paper, you will find that the ruler can attract the small pieces of paper. As a result of the ability, equipment has been invented to remove small dust in the air, such as a dust remover in a factory and an air cleaner. 2. An electric charge has an exerting force towards another electric charge. There are 2 types of electric charges, which are a positive charge and a negative charge. Objects which have electrical charges will have forces toward each other. The forces are pushing force and pulling force. The force that results from both charges will have great amount. According to an experiment in 1780 done by Charles Coulomb, a French physicist, to find the amount of electric charge, it is concluded that the amount of force is directly proportional to the amount of both charges, but is inversely proportional to the square of the distance between both charges. Coulomb's law. Provided that Q1 and Q2 represent the amounts of both charges of which unit is coulomb. R represents the distance between both charges of which unit is meter. F represents force that occurs on both charges of which unit is Newton. K is a fixed amount which equals to 9 times 10 to the 9th power, Newton meter squared, divided by kilogram squared. Electric field. Electric field is an area where there is an exerting electric force on other charges. The electric fields have different characters according to the type of charges and the shape of an object which contains the charges. If the object contains positive charges, the direction of the electric charge is going out of the object. However, if the object contains negative charges, the direction of the electric field is coming in. Picture: electric field from positive charges and electric field from negative charges. Picture: electric field from two metal plates. In an area which has an electric field, when a charge is passing or brought to the electric field will exert a force on the charge. The direction of the force is the same as the direction of the electric field, if it is a positive charge. However, the direction is opposite to the electric field if it is a negative charge. 1. Structure of atom. An atom is composed of three types of particles, which are protons, electrons, and neutrons. Protons and electrons stay in the center called nucleus, while electrons circle around it. There is a centripetal force, which is the attracting force among the charges. This force is the reason that electrons can circle around the nucleus. 2. The removal of dust and soot in the chimney. In industrial factories, which have combustion activities, the soot will go up a chimney and spread out in the air. The removal of dust in the soot is done by setting up an electricity pole with high voltage in the middle of the chimney. When the soot passes through the chimney, the electricity pole will cause the soot and dust to receive charges from the electricity pole and have the same kind of charges. The soot and dust is pushed to the wall of the chimney and does not spread out in the air. Picture: structure of atom. Dust, chimney, electricity pole. Picture: chimney. 3. Paint coating. In coating paint on the body of a car or coating paint on metals, it is done by making charges of the paint opposite to the charges of a car's body or metal. When coating, the paint will stick with metals or cars' bodies better. Magnetic forces. A normal magnet will have a north pole and a south pole. When placing a magnet, there will be forces exerting on magnetic particles around the magnet. We call this area magnetic field. The direction of the magnetic field is going from the North Pole to the South Pole on the magnet. The lines that shows the directions are called magnetic lines of force. Picture: direction of magnetic field. Property of magnets. 1. Pulling force or pushing force exerting on certain substances. A magnet can pull or push certain substances. We call these magnetic substances, which are divided into three kinds. Ferromagnetic substances are substances that have very strong pulling force with a magnet, such as iron, nickel, and cobalt. Paramagnetic substances are substances that have weak pulling force with a magnet, such as manganese, platinum, and aluminum. Diamagnetic substances are substances that have pushing force with a magnet, such as phosphorus, bismuth, and antimony. 2. Pulling force and pushing force on magnets. For the same pole of magnets, the forces are a pushing force. Alternatively, the different pole will pull each other together. Picture: force between the two magnets. 3. Magnetic force on an object containing electrical charges. If a small particle passes through a magnetic field, forces from the magnetic field will exert on electrical charges, and the direction of the forces will be like holding the right thumb up with pointing finger as demonstrated in the picture. Direction of a force: direction of a moving charge, direction of a magnetic field. Whereas F represents a force exerting on a charge, Q represents the amount of charges on a particle passing through a magnetic field, V represents a speed of the particle passing through the magnetic field, B represents flux of the magnetic field. If there is a charge moving through a magnetic field, the magnetic force will deviate the course of the charge. If the magnetic field is wide, the charge will go in a circle. Note, if a particle contains negative charges, the direction of the force will be the opposite of positive charges. Picture: positive charge moving in a magnetic field. 4. Force exerting on wires where electric current flows in a magnetic field. When a wire with a flowing electric current is put in a magnetic field, it will be like there is a large number of electric charges moving through a magnetic field, which results in a force exerting on the electric charges in the wire. Therefore, the force that occurs will be a force exerting on the wire. The amount and direction of that force will be the same as the one exerting on the charges. It is just that the direction of the charges is moving in the same direction as the electric current in the wire. Picture: force on a wire. F represents a force exerting on a wire. I represents electric current flowing in the wire. Lambda represents the length of the wire. B represents a magnetic field. Notes: force exerting on a wire will be at the middle of the wire. Magnetic forces. Nuclear force is a force happening in the nucleus of a substance. It enables many protons to gather in the nucleus even though those protons are the same kind of charges which have pushing forces. Protons and neutrons are able to gather in the nucleus because those particles attract each other by nuclear force. The energy which particles attract each other is called binding energy. According to Einstein's theory, the binding energy comes from the loss of mass. The amount of mass defect is calculated from the mass of nucleon, which is the sum of protons and electrons' masses minus the actual nucleus's mass. For example, the nucleus of helium has 2 protons and 2 neutrons. When summing up the 2 protons and the 2 neutrons, it is found that the amount is greater than the actual mass of helium's nucleus. Therefore, a part of the mass disappears and becomes binding energy in the nucleus. Combining forces. When there are many forces exerting on an object, the forces affect the state of the object. For example, the object may stop, move, or change directions. The state of the object, on which forces exert, is a result of the total forces which exert on the object. The combination of the forces is one force called resultant force. Moreover, if the resultant force is 0, the state of the object is stopping or moving with constant speed. However, if the resultant force is greater than 0, the object will move with acceleration. In combining forces, we have to consider directions of force. Therefore, when we combine the forces, we will combine the directions of the forces by lining up the arrows. That is, the tail of the second arrow will connect with the head of the first arrow, while the directions of the arrows stay the same. 1. Combining forces in one dimension. In finding the amount of a resultant force, we will consider the directions of forces. If the directions are the same, we will sum the amounts of the forces. However, if the directions are opposite, we will subtract the amounts of the forces. 2. Combining forces in two dimensions. In case that the directions of the forces are not moving the same way, we cannot add or deduct the amounts. The amount of resultant force is found by drawing. It is done by connecting the second vector's tail with the head of the first vector. The amount of a resultant force can be found by drawing a line from the tail of the first vector to the head of the last vector. 3. Combining forces by separating forces. It is a combination of many forces exerting on an object by separating forces on the x-axis and the y-axis. Then finding the sum from each axis so that it will be easy for combining the forces. When the forces are on the same axis, if they go in the same direction, sum the amounts of the forces. However, if they go in different directions, deduct the amounts of the forces.